So in today's lesson, we're looking at electric circuits. So there's three learning objectives today. Explain why a series or parallel circuit is more appropriate for a particular task, a particular job. Understand why current is conserved at the junction in a circuit. And know that voltage across two components in parallel is the same. Right, so what is a circuit? So basically a circuit is basically a complete and unbroken, can't have any breaks in it, otherwise electricity will not flow, and it needs to contain a power supply, either a current, a cell or a battery. And a circuit diagram is used with standard symbols so everyone understands what circuit you have created. So we have to go through those circuit symbols. Okay, so these are the circuit symbols. So the cell is basically a device that allows electrons to be pushed around a circuit, provides that energy, and a battery is two cells. A wire is just the connecting kind of conductor, and that's always drawn with straight lines, so remember your rulers for exams. And we have wire junctions as well, where the wires join. And we have a switch. Now the switch, if it's open, it means that the circuit is not on, and if it's closed, then it means the circuit is on, okay? So how do you know it's on or off? We use an indicator, primarily a lamp. Okay, so when the lamp bulb is on, it means the circuit is closed, and when the light bulb is off, it means the circuit is open. And we can measure current in amps using an ammeter, and we can use a voltmeter to measure the voltage in volts. So in terms of resistors, okay, so a resistor is a device which kind of slows down the current. So you have variable resistors, which means you can adjust the resistance to adjust the amount of current flowing. And we have two special types called the thermistor, which means that more current flows as temperature increases, and the light-dependent resistor, which is more current flows with increasing brightness. We have the diode, which only allows current to flow in one direction, indicated by the arrow, and a special one, the light-emitting diode, which emits light when the current flows through it. We have fuses, which of course melt if the current gets too high, and a heater, which converts the electrical energy of a circuit into heat energy. So in terms of electric current flow, we have to be very careful here. Current flows from positive to negative. So even though the electron is the charge carrier, in physics, the charge flows from positive to negative. So you have to be very careful with that. And the longer, thinner line of the symbol of a cell is the positive terminal. So you have to get that the right way around as well. So here we have a circuit diagram where it's going from the positive terminal to the negative terminal of the cell via a diode in one direction to make that radio work. So there's two types of circuits. There are series circuits and parallel circuits. So in series circuits, the current which passes through each component is the same. So the supply current IS equals the current passing through component number 1, which equals the current passing through component 2 in the diagram. So you'll see that all 3 amps. In terms of voltage, in a series circuit, the supply voltage is going to be the sum of all the individual component voltages. So here we have a circuit with 3 lamps. So the supply voltage Vs is going to be the current, the voltage going through the first lamp, the voltage going through the second lamp, and the voltage going through the third lamp. Okay, so it's going to have to add those together to get the supply voltage. Then we have parallel circuits. So the voltage across the components in a parallel circuit are going to all be the same. Okay, so here we have components X and Y in parallel. So the supply voltage will equal the voltage 1 across component X, which will also equal the voltage across component Y, voltage 2. So they're all going to be the same. Now, in a parallel circuit, one of the advantages is that you can control each of those particular branches with a separate switch. So if one light bulb blows, not a problem, because you've got two other light bulbs which can still go, even though that one part of the parallel circuit has been broken. Quite useful. So in terms of currents in parallel circuits, the total current through the parallel circuit is going to be the sum. Okay, so here we have a parallel circuit with two components, the lamp and the resistor. So the current going through the lamp plus the current going through the resistor will equal the supply voltage. Okay, IS equals I1 plus I2. And then finally, what are the advantages of parallel circuits over series circuits? Well, when connected in parallel, the advantages are that the lamps are brighter than compared to those connected in series. The lamps are controlled individually by switches, which we looked at previously, and one lamp will continue working even if others are not in parallel. So that means it's quite useful. So for example, Christmas lights in series, so if one of those bulbs blow, you've got problems because the entire lot go, because they're all in series. Whereas if it was all in parallel, even if one Christmas light blew, you could still get the other ones to work.